All right, so what we have here is our standard IP address. That was the other question I forgot to ask. What class is the IP given? So we'll answer that question first. So, based upon this number here, we know that it's a what? It's a class C, right? I'm going to kind of ask the questions and answer them myself, so if you think it's something that I don't say, you know, like I said, throw a hand up, let me know. But since it's 192, we know that's a class C. Okay, so we know that's a class C. All right, now we can go back up here to the other top. This, if you'll remember, is a CIDR, C-I-D-R. And what this number tells us is how many bits are turned on with the subnet mask. So, we just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and then 28, 29, 30, 31, 32. Because remember, each one of these is an octet. So we got 8, 16, 24, 32. Okay? So we got to turn them all on even if we're not using them. Now, if you take all of the bits and you turn all of them on, that equals 255. And remember, in each one of these octets, there is 256 total addresses. And what this number says is that out of those 256 total addresses, 255 of them ain't it. Okay, so that means this has to match. So we got all these bits turned on, 255. We got all these bits turned on, 255. Now, with all of these three sets turned on, that is the setting for a default class C subnet mask. Okay? So remember, so any number here that is higher than 24 is going to be turned into a class C. Okay? Because remember, with a class A, it's 255.0.0.0. With a class B, it's 255.255.0.0. With a class C, it's 255.255.255.0 by default. Okay? So, since we've gotten higher than 24, we're now into the fourth octet. How many bits did we borrow into that octet? Well, we went to 24, so there's 25, 26, 27. So 1, 2, 3. So the number of bits borrowed is 3, because that's how many we took out of the fourth octet. We used 3 bits. So we can look at our numbers, which remember, these are set in stone. They don't change. So we would turn on 1, 2, 3, and then leave the rest of these off. Okay? So what we would do is we would say 128 plus 64 plus 32. So 128 plus 64 is 192, plus 32 is 224. So these 3 bits turned on gives us the value of 224. So that tells us that our subnet mask is 255.255.255.224. Okay? Now, with that being said, now we can look here. This is the last bit that we've turned on. So what we're going to do now is we're going to look at this value, the value of the bit itself. Now, the value of the bit itself tells us how many total addresses there are in that subnet mask. So we look here, how many total addresses are there? There's 32. Well, remember, every subnet has to have a network address and a broadcast address. So that's 2 addresses that you cannot dish out. They're not usable. They're not host address. So if I say how many usable addresses there are, Yeah, the usable number of addresses, I would say 32 minus 2 equals 30. So we've got 30 usable addresses. Okay? Now, what is the number of subnets made? Now remember what I said about how these numbers are set. Now, if we went into the third octet, then the number that's over here would actually be 256. Because remember, each one of these is half of the previous one. So if we were actually into the third octet, or we had that dot right there, that first value would actually have the value of 256. So what we can do is we can actually flip them. And we can say 256, 128, 64, 32, 16, 8, 4, 2, 1. So we just flip the numbers. Okay? Now, what does that tell us? That actually tells us the number of subnets made. So if I could have 256 subnets of one address, which is useless because it's nothing but the network address. There's absolutely nothing you can do with it. I could have 128 subnets of 2 addresses, which are still useless. Why? Because that would be the 2 addresses that I have to have for it to actually be considered a subnet, a network address and a broadcast address. So if I've got nothing but a network address and a broadcast address, I have nothing I can give out. That would just be me standing here yelling at myself. Because all I would have is a broadcast to a network. That's it. So, you'll never go past 4. Because I can have 64 subnets of 4 addresses. And that would be the least amount I could have. Because think about it. I've got my subnet, I've got my network address, and I've got my broadcast address. So, if I've got my network address at the front, my broadcast address at the end, that gives me 2 addresses in the dead center that I can give out. So that would be 0, 1, 2, 3. So that would be a point-to-point, 1-to-1. So dot 1 talks to dot 2. If you want to talk to both of them, you'd send the address to dot 3, which would be the broadcast, and there you go. That is the least amount you could dish out. And I could have 64 of them. So now we'll just skip on down. We look at our value. We've turned on this one. So we know we got 32 total addresses. We got 30 usable addresses. And we've got 8 subnets. So we now have, if we drew our, kind of network out, it would actually be like that. 8 equal sections of 32 addresses. So our number of subnet masks made is 8. Now, we can go over to the chart I showed you. So, if we know that 32 is the total number of addresses that we have available, then we know that the 33rd address will be the network address of the next network. Okay, so think about it. So if I've got 32 addresses, then the last address, that 32nd address, is going to be the broadcast address of my current network. So then remember how I said the first address is the network address and the last address is the broadcast? Well, if the first address of any of them is 0, then the 33rd or the 32nd address will be the broadcast, because that's a total of 32 addresses. So then the very next number will be the network address of the next subnet. Okay? Because it's the next address that's outside of the 32 total. Now, here's the thing though. And this is what's really nice about the way you do with networking, or what actually helped me out, is think about this. Normally when I tell you to count, you'd go 1, 2, 3, 4, 5. Okay, well remember, with networking, 0 is a usable number. So technically you're counting 0, 1, 2, 3, 4. Okay, that sounds kind of like, oh Lord, my math teacher's going to shoot me now. But it actually helps us out. Because if you're counting 0, then that means that the 33rd address would not be 33. it would be 32. So all you have to do is look at the total number of addresses you have and add it to 0. So 0 plus 32 is 32. 32 plus 32 is 64. 64 plus 32 is, let's see, so that would be 96. Now, I'm going to show you something with this, and this is what you'll see on the test, is that what we're really focusing on is this number right here. Okay, so if we're looking for where 68's at, I really don't have to go past 96, right? Because we know it's not going to be past 96. You can go ahead and fill out this chart all the way to the end. And like I said to y'all before, the reason I like making this chart is because as long as this number stays the same, this IP address could be anything. It could be absolutely anything. It could be 193.16.2.108. It could be 10.10.10.57. It could be anything, absolutely anything. Because if this number stays the same, this is 100% accurate. It doesn't matter if I put a Class A address up here, a Class B address up here, any address I want to put, regardless. This right here makes it this. So even if I wrote 10, 10, 10, I could write 1115. This right here still makes it a Class C address because this tells us we've locked down the first one, we've locked down the second one, we've locked down the third one. So now by default, it's a Class C subnet, period. So anything after here is borrowed into the Class C. So that's how you make a classless subnet. And that's, remember, this number doesn't match what you've turned on. Because if I made this 12, if I erased that 9 and made it a 12, that's a Class A subnet. So the subnet mask should be 255.0.0.0. But remember, our CIDR tells us how many bits are turned on. So anything higher than 24 automatically makes it a Class C subnet, period, regardless. Now, that may sound a little bit confusing or a little bit like, oh God, why did you throw that out there? I threw that out there because it makes it easier. Because what I'm telling you is that if this number is higher than 24, and if it stays, if it's this number, then regardless of what this is, I can write anything under the sun for those numbers. This makes that 100% accurate. Okay, so what's the point, Mr. McSwain? The point is this, is that if you're taking the test and you've got 10 questions, and all 10 questions ask you these kind of questions, but it changes this IP address 4 different times, as long as this CIDR stays the same, you can answer all 10 questions with your chart you've made. Because this is 100% accurate, because all you're focusing on is this last number. Okay, so that's why I'm telling you I like the chart, because as long as this number is consistent, this is consistent. Get back on. Okay, so the question is how did we get our subnet mask of this?
I got that one.
This bit. You have to turn on that bit, and I've wrote it up here and down here because what you got to do is add 128 plus 64 plus 32. And what the subnet mask is. Once you've added the values, that's the only one time you have to do it. From then on out, you just focus on the last bit you turned on. So if I went all the way down to like here, then I would add all these together and get 252, and that's the only time you'd see it's from a subnet mask, but that's what tells us our total number of addresses. So now we've got our network address of all of the networks past 68. So now all we got to do is, if this is the first usable address, then that means that the last usable address of the previous one would just be this number minus 1. So the broadcast here would be 95, 63, and 31. Then everything in between is a usable address. Like that. So now using my chart, I can check it. This is just a real quick once over. Even numbers, odd numbers, even numbers, odd numbers. So I know I did my math right. Even, odd, even, odd. Okay, so now I can say, okay, where is 68 in my chart? Okay, 68 is probably going to be like right there. So then that tells me, what's my network address? Dot 64. What's my broadcast address? Dot 95. And that's it. That's it. Okay? So now, let's do one more. Now that y'all have me run through it again, I want y'all to do one more, and then I'm going to show y'all yet another way. Because I always wait for this last way until I get y'all down pat with this method, because I don't want you to jump to this other method I'm fixing to show you right off the bat, okay? And then we'll talk just a little bit about class list subnetting, and then we'll jump into chapter 6. Answer of all these questions except this one. Because remember, anything higher than 24 automatically makes this a C. I'll give y'all that answer. And yes, if you want to know how many bits borrowed, now this only works for a class C. So don't set this in stone, it's only for a class C. You actually can do even an easier step. You don't want to make all them zeros out there? There's how many bits borrowed. Because remember, 24, so if I've got 24, that automatically makes it a 255, 255, 255 dot something. So if I've got 2 bits turned on, boom, boom. I add those 2 values together, 192. It's amazing how I told y'all to do it. Here I am doing it for you. You could actually go less than 24. But what you're doing is you're making this a class list address. So if I were to say 18 for my CIDR, then even though this says 192, if I've only turned on 18 bits, then of course I'm in the 3rd octet, right? And that's going to make it a class B address. Gives me more addresses to use here and here, because if you think about it, for every 256 addresses here, there's 256 of those 256. And then here there's 256 of those 256 of those 256. So really what you're looking at is, you know how we drew our little chart here to say that was our, anything from 1 to 254, and then we had 0, and then 255 down here? Well, every one of those here, so if you drew this, and then you drew this is in here. And this is in here. So, for every 256, 1, 2, 3, there's one of these in every one of them. So now you see how it exponentially gets bigger in every class that we go to. So that's how you go from having 256 usable addresses to so many thousands of addresses to so many hundreds of thousands of addresses. Because it's kind of like, have y'all ever heard the old story about the guy who gave advice to the Sultan, and whenever the Sultan said, I'll give you whatever you want, he had invented chess, and he showed the chessboard to the Sultan. Stop me if you've heard it, but this is actually pretty interesting. So years ago, this Arabian, he was a genius. He was a mathematical genius, and he developed chess. And so he took it to the Sultan, and he showed the Sultan the game of chess and how it was basically war strategy on a board. Well, the Sultan was so amazed by this game that he said, I'll give you whatever you want. You tell me whatever you want, and you can have it. And the gentleman looked at him and said, all I want is a single grain of wheat to be doubled per square. So on the first square, I want 1 grain of wheat. On the second one, I want 2. and on the third one I want 4, and so on and so forth. Well, the Sultan was like, you can have anything. I'll give you 250 bags a week. And he goes, no, I want that. And he goes, you can have gold, you can have whatever. He said, no, I just want that. Well, the Sultan kept thinking about it, and he was like, why does this guy only want this? I don't get it. He's a genius. He made this game. Why does he only want that? And so the Sultan called in all of his other, guys that were the advisors and everything else, and they sat down and they started calculating how much it would be by the time it got to the end of the chessboard. And they go to the Sultan and they said, sir, we figured out why he's asked for that. And he said, why? Tell me. He said, because once you double everything exponentially, by the time you get to that 36th space, there's not enough grain in the world to meet that amount. There's not enough grain in the kingdom, in the world, to give him that much wheat. And so the mathematician sitting over there in the corner smiling, because then he got what he really wanted. The Sultan made him an advisor. So what I'm getting at is you can see how even though we're only working with 256 usable addresses, you have to compound that 256 times to get a Class B address. Then you got to compound that into that, and then compound that into that to get a Class A address. So you're getting into the hundreds of thousands of addresses. But what really throws you off, if you really think about it, is the fact that we ran out. There are no more. We put so much stuff on the internet and gave so much stuff an IP address, we don't have it. As of 6 months ago, there's no IPv4 addresses left. There's no public ones, they're done. We've used them all up. That's why we're shifted into IPv4 or IPv6, because in IPv6, with hexadecimal, you go from having hundreds of thousands, and now you're in the billions and trillions. It's ridiculous. And so, back to my story of the Sultan and the chessboard is basically they said, okay, we started out with this little travel board game that's IPv4, and now we've turned it into the big game, and there could never be, and the idea is that there could never be enough devices ever made that we would run out of addresses using IPv6.
Before the world ends.
Exactly. So we know that by turning on those 2 bits, we've got 192 is our subnet mask. How many total addresses do we have? 64. So if we take 64, subtract 2, we got 62 usable addresses. How many subnets did we make? We flipped the numbers over, and we know that by 64 total addresses, we've made 4 subnet masks. So if we drew out our diagram of our network, we've done that. So we've got 4 sections of equal 64 addresses per section. So whenever we look at that, we've got 64. So 0 plus 64 is 64. 64 plus 64 is 128. Because we're only looking for 68, we don't need to go any higher. So since this is the network address of the next subnet, then we know that the broadcast of the previous one is 1 minus, so that's 127. And then the previous one for this one would be 63. So then everything from 1 to 62 can be dished out here. Everything from 65 to 126 can be dished out here. We know that 128 is probably going to land right there. So we know that our network address is .64 and our broadcast address is .127. Now, whenever I say this, keep in mind that I'm not just saying that the answer is .64. The answer is actually 192.168.10.64. But because we're working with a Class C, remember that every octet we turn on that makes this 255, then this is locked down. And this is locked down, and this is locked down because of the 24. So because these are locked down, I don't really have to focus on it. So that's why whenever I'm making my chart, I'm only focusing on this octet. Because the rest of these don't matter. Because I already know it's gonna be 192.168.10. something. And that's what the 24 does. It locks these down. Because remember, 255 out of the 256, 255 of them ain't it. I told you what is it. So there you go. So whenever we're doing Class C subnetting, you only have to focus on the last octet. All right. Now, using the methods that we've already looked at, I'm going to show you a new way. Now, please keep in mind that the reason I'm showing you this method now is because I think everybody in here now has at least a vague grasp of subnetting, right? Does everybody at least have a vague grasp? Everybody feel at least okay with it? I mean, not proficient.
I could use practice. But
Yeah, well, everybody needs practice.
Yeah.
But at least you know what I'm talking about. Okay, good. And the reason why that's great is because I'm fixing to show you a new method. This method is actually easy. But here's the thing. Even though this method is a little bit easier to find the answers you're looking for, it only works when you have a CIDR. Okay? It only works when you have a CIDR. So, if I said 192.168.10. We'll just go ahead and pick a big number. 135 with a CIDR of 29. Okay? That's a lot for our chart.
Does it only work with a...
The method that I am showing you now is called ANDing. Okay? ANDing. Now, what that does is we've actually already covered everything you need to know for ANDing. So, based upon our CIDR, we already know what? If we said minus 24, we know that we borrowed 5 bits. So the bits borrowed is 5. That answers that question. We turn on 1, 2, 3, 4, 5. Leave the rest turned off. So we know that we've got 8 total addresses, 6 usable addresses, and we've made 32 subnets. And somebody get out a calculator for me, because I know that it's actually, you know what, 256, 255, 253, 248. So, because we've turned on all of those bits, we know that our subnet mask is 255, 255, 255, 248. Okay? So, if you'll notice, I've literally answered all of my questions already, except for what's the network address and what's the broadcast address. Those are the only 2 answers I have not got. So, I can make my chart, a handy dandy little chart, but keep in mind, I'm doing it by 8s, and I'm going all the way to 138. So my chart's going to get pretty big pretty fast, right? Well, here's ANDing. ANDing is if I take the binary of the subnet mask and I compare it to the binary of the IP address, then I can determine what the network address is. Okay? Now, remember, we've already turned on the first 24. So this one's locked down, and this one's locked down, so which one we got to focus on? This one right here. Okay? So keep that in mind, that whenever I'm doing this, I'm still only focusing on that 4th octet, including with the subnet mask. So I can write out all the ones over here, but the answer's going to match until we get to the 4th one, because we're in a class C. So now watch what I'm doing. We remember how to do binary, right? You remember how to convert to binary. So we got 135. Will 128 go into 135? Yes, it will. So 135 minus, I wrote that wrong, 128, that's going to be 15, so that'll be 7. So will 64 go into 7? No, it won't. 32? No, it won't. 16? No, it won't. 8? No, it won't. 4? Yes. That leaves 3. Turn on the 2. Turn on the 1. Okay? So everybody knows that part, right? Pretty simple. Self-explanatory. We've done it a couple of times. Now, here's what I want to show y'all. So, I've got my, I'm just going to go ahead and move it down here. 192.168 10.135 with a cider of 29. So I just moved it, that's all it did. Now I'm fixing to show y'all Andy. Alright, so we all remember the good old, y'all seen the Progressive commercials with Flow? And we all know that sprinkles are for winners. I like that too. I like ice cream and I like sprinkles. Pratton uses beer and wings. I kind of keep it on a PG level, so I'm going to say ice cream and sprinkles. So here's the concept. If I've got ice cream and I've got sprinkles, I'm happy. If I've got one or the other, I'm not happy. So ending is simply this. I've got ice cream, I've got sprinkles, I'm happy. I've got ice cream, but I don't got no sprinkles, I'm not happy. Got ice cream, no sprinkles, not happy. Ice cream, no sprinkles, not happy, not happy. I got ice cream, or I ain't got no ice cream, but I got sprinkles, that's just weird. So no, I'm still not happy for any of those. So, if I take all of this and I look at it, what is the value of the bit turned on? So if I added all of these values together, what's the answer? 128, because that's the only bit that's turned on. So, since that's the only bit that's turned on, that tells me because I got to add the value of all these bits together. And when I add the value of all these bits together, that's what it equals. Guess what? That is my network address. That's the answer. So if I did my whole chart all the way down, I can verify that that is the answer. So if I've got 8 bits that are total, I can say 128 plus 8. So 128 plus 8, that's 8 and 8, 16, carry the 1, 3, 136. That gives me the network address of my next subnet. So then I subtract 1, remember, because we're looking for the broadcast, subtract 1, and I know that 135 is my broadcast address. This one's even, this one's odd. There you go. That's it. That is how you find the network address and the broadcast address using AND. You take the binary value of the subnet mask and you compare it to the binary value of the IP address you're looking for. And if both bits are turned on, then that's going to be your network address. Okay, now when I say that, remember we're still dealing with a Class C. So technically I could have said 192, which is 11123456. Dot 168, which whatever it is, 101011110, something like that, and then 10.000010100. That's way too many zeros. Like that, and then dot whatever one